Hello, my friends. Today we are continuing the video blog series on thekernel.com, and my guest today is Greg. Hi, Greg.
Hi, Anton.
So we have presented, or we have prepared together with Greg, an interesting topic that is being discussed in the industry these days very intensely. Probably you could hear that each and every presentation, each and every video series, I'm intending to say that we are talking about something super interesting. Probably the reason why I'm saying this, because we are trying to create something not interesting for you and just not again to explaining the how to configure OSPF or STS or something like this. So that's our topic for today, friends. Resource public infrastructure origin validation sounds probably very long, but we hope that together with Greg, we will go into the details so that you will realize why it is necessary and what is it in general. So let's get started. If you haven't seen my previous series, and if you don't know who is Greg, that is who is Greg. So Greg Hankins is a senior project manager. He is working in the Nokia and responsible for the kind of advanced products. You could hear his speeches on some events like NANOC or PRNTB, or obviously also Nokia SR experts, especially if you are attending such kind of events in the US. Also, Greg is very actively working not only, from the presentation of some Nokia products, he also contributing a lot to their IETF, RFC, and a couple of them like the community for BGP and some others for their RFCs where Greg were co-authoring. He's working in the industry for quite a long time, so more than 20 years or even close to 30, and you could follow him on LinkedIn. So thanks for your time, Greg. I really appreciate that you I know that you're a very busy man, and to find the time in your schedule is not that easy. So let's go to the details. So if you think about the internet, so what could happen in internet to get it down? What do you think?
So this is a great question, Anton, and one that's very relevant. We just had an incident last week with a major service provider and a route optimization software that actually caused a pretty major outage on the internet, and this all could have been prevented with proper filtering and with RPKI origin validation. So let's just walk through a quick example, and there are a number of different scenarios, but this is just a simple one to illustrate. In this case, customer 1 has a prefix that they're advertising, which they own. It's a correct update, as you can see in green. And customer 2, by some means, either accidentally or maliciously, announces a route with a longer prefix. So the way that the Internet Routing Table and BGP works is that the longer prefix then is selected as the best path. So obviously that prefix would then be propagated through the ISP and onto customer 3, which creates an incorrect routing scenario. So in this case, customer 3's traffic is no longer going to customer 1 as expected. It's now going to customer 2, which is incorrect and not what they want.
Okay, so you said very important topic that this could be done intentionally or unintentionally. From what you have seen in the industry, what is like the most major case? Is it intentionally, like somebody would try to steal somebody, or just, I don't know, by kind of mistake or human type error? What is the reason?
Yeah, that's a great question. So we've had a long history on the internet of BGP accidents, and some of them are intentional. There's a very famous incident several years ago where Pakistan hijacked YouTube's address space by announcing some more specifics. And then there's also an unintentional event like the one that happened last week with the BGP route optimization software that just sent more specifics for a lot of routes. So that was unintentional. We've also had just various accidents over time where someone announced a full routing table to the internet that was accepted and things like that. So all these things can be prevented with, there's really two things that go together. One is proper filtering, And the other is that RPKI can be used in addition to filtering as another cryptographic layer of maintaining routing information and validating routing information. And that's really the challenge here, is you want to validate which routing information is actually correct, and cryptographically signing that information is a very powerful tool in order to indicate the validity. So obviously, in your third box, what happens is that the service is unavailable, and that can have varying impacts. So in the YouTube case, people just couldn't watch YouTube videos. But if someone intentionally hijacks a prefix, for example, for a banking or financial application, there can be some real serious security incidents involved in this type of a hijack. So it just kind of varies depending on if it's intentional or unintentional, but there are very specific BGP hijacks that have taken place in order to steal customers' data. And this is a very dangerous situation that we want to prevent.
Okay, fully agree. Actually, for internet, it doesn't matter what was intentional or not intentional occasion. The important, the traffic is not working, right? So, and you pointed that it kind of validation with even cryptographic sounds like, kind of magic. And let's probably take a closer look what exactly it's about. So how really this validation is working, how to understand what is good, what is not, what is allowed, what is not.
Sure. So before we talk about in detail how it works, this is the basic concept. You can basically cryptographically sign a prefix with a length and an origin ASN. And this is done by the owner of the prefix. So if I have this prefix, then I have tools where I can cryptographically sign this and specify which origin ASN this prefix should be advertised from. And there's three actions that are listed here. One is valid, so that's if the signature is valid. That means the prefix length matches and the origin AS matches. There's also invalid. That's the case where someone is deliberately or unintentionally sending either or originating the route from an invalid ASN, or in some cases sending a more specific that's not permitted by the cryptographic signature. And then the last case is unknown. This is if there's no signature found, then the state is unknown and you really don't know. So what operators are doing is they've started to drop invalid. And this is a very safe case because you know that the cryptographic signature is invalid, therefore the routing information is wrong, and therefore there's very little risk in actually dropping invalid information. You probably wouldn't want to drop unknown because that's a less safe state of the prefix that you want to investigate. So it could just not be cryptographically signed, but still valid. And in that case, you can check other databases like the RIR or specific filters that you've written for that peer or something like that. So there are other actions that you can take if the cryptographic signature is unknown.
So it sounds for me, because for me, this concept is for me new, but I'm, have worked quite a lot with all kind of VPNs. And for me, it sounds like very familiar to this, let's say, PKI, so public infrastructure, where you use certificates to build IPsec tunnels. It's kind of the same, but just for BGP routing, isn't it?
Yes, it's cryptographic signatures on routing information instead of data that goes over the internet.
Okay, good. So, folks, if you are a bit surprised about this concept, or just it seemed weird for you in the very beginning, now you could just compare with something more traditional, like traditional certificates for your IPsec, and that would help you to understand the concept. So, fine, we have like understanding how or what is actually is done. Let's take a look how it is working and how the people could understand if or where they could find information, what is allowed, what is not.
Yeah, so that's a good question. Whenever you're originating prefixes or on the internet, you want to make sure that the other routers are accepting what you expect you are sending. So a way to do that is through a Lookingglass, and there's a great one that the ring at NLNOG maintains. The URL is lg.ring.nlnog.net. And using that tool, you can query several routers that collect routing information and show you the prefix. So in this case, This is a prefix that I own. I originate from IOAS 38016. And you can see that I've signed it, and I've enabled RPKI, and the RPKI signature matches and is shown in that extended community where it shows that the RPKI origin validation state is valid. And that means that I've signed the route correctly and it's propagated correctly, and the router that received the route was able to do the origin validation and confirms that it is indeed a valid route. So if it were invalid or unknown, then it would show up in that same field right there, in that same line right there. It would just say unknown or invalid. So this is a great tool to look at your routing announcements on the internet. It also shows you a number of other interesting things, like the communities that it's sent, or the large communities that are attached to the route. Any sort of other path attributes, like the AS path is interesting, the local pref and things like that. So it's just a good way to verify the routing information that you're sending on the internet.
Comparing this slide to what we have seen in the previous one, we was discussing about like particular route.
So in the previous one, you would have seen either unknown or invalid on that line there.
Yeah,
you have highlighted. Yeah, exactly.
And that's
a good way to check the validity of your origin validation.
And the next question that probably would be the last for this slide. So what we really let's say sign. Do we sign this 24 or do we sign this 16?
Yeah, so that's a good question, and that's really up to you.
Okay.
If you sign a /16, for example,
mm-hmm.
then it will apply to any more specific announcements. But it has to match the AS that you sign with the /16. So if I sign the /16 with AS 38016 and then have a more specific coming from a different ASN, then that would be invalid because I've signed the /16 with 38016 and coming from another AS is a validation failure.
Okay,
so
good.
That's a good point, is that if you have a number of longer prefixes, you don't have to sign all of those. You just have to sign your aggregate or your supernet that covers all the prefixes, and that saves you a lot of work too. In this case, I just decided to sign all of mine because I only originate 3 prefixes, so it wasn't a lot of work.
Okay, good. That makes sense, especially for the service providers who really aggregate or who provide.
Yes.
Exactly.
And that's a great point.
Let's take a look then how this whole structure works. So once we understand how this table of resources looks like and what is valid, what is not, let's take a look how this put together with the whole infrastructure.
Okay, so this is a little bit of a complicated diagram, and we need to spend some time on it. So the new piece in here is the RPKI validation software. And this is a piece of software that runs on a server, and the router uses the RPKI origin validation protocol in order to communicate with the validator. The validator communicates with something called the TAL, or the Trust Anchor Locator, which is a source of cryptographic authority that is run by the RIRs. So it doesn't have to be run by an RIR. You can run your own anchor if you would like and provide your own origin validations, but it just happens to work out that the RIRs are already the source of authoritative data on addresses and address allocations in their region. So the RIRs have worked very hard to also build in RPKI tools into their portals so that you can just click a few boxes and enable RPKI on all of the prefixes that are assigned to you by that RIR. So for example, in the European region, we have RIPE. RIPE has been probably leading the efforts in RPKI validation. So they have a lot of tools. They also have a validator software that they've written. And if you go to the RIPE webpage, then you can log in to the portal there and enable RPKI. It's very simple. So this information then is rsynced to the RPKI validator. You can choose how often you want to do it. Some people do it every hour. Some people do it every day. Some people do it several times a day. And that transfers all of the information from the RIR to your local RPKI validation software. That software then communicates with your router and communicates the validity information. So that communicates whether it's valid, invalid, or unknown. And then you can configure BGP to actually take action based on those states. So you can, for example, set a lower local preference, or you can reject invalids, for example. Say you have valid routes, you know that those are valid, so maybe you set those to be more preferred so that a valid route would be preferred over an unknown, for example. It's really up to you and your routing policy as what you want to do with this information. But as I mentioned before, a very safe decision is to drop invalids, and that's a step that a lot of major providers have taken, like AT&T, which is AS7018. It's a very large Tier 1 ISP. Last year, they announced that they're dropping all invalid routes. And again, that's a very safe thing to do because you know that the routing information is cryptographically invalid. So why would you want to have that information in your routing table? It just doesn't make sense to accept something that is known wrong into your routing table. So that's a really good first step. And then using our example from the previous couple slides, now you see that the BGP update in red, which is cryptographically invalid now because it's being announced from the wrong ASN, would then show up as invalid in RPKI origin validation and would then be dropped if you've configured your router to drop the prefix.
So it means that in this case, if, say, we have a customer, one hosting any kind of service, and intentionally or unintentionally customer two announce it like part or more specific prefix, it would be dropped by their ISP, and therefore the customers would safely reach their service.
Exactly. It would be dropped where you have R2 circled there on the BGP session, and then it wouldn't even be propagated into the ISP network, and certainly would not be propagated on to customer 3.
Okay, that makes things logical because we understand that really it's like having a certificate for building the tunnels. We have certificate either to accept or not accept the route because they are not, let's say, originated properly.
Exactly.
So running put together, right? So that's exactly what I was thinking when I was discussing this topic. Yeah, it's exactly what we are doing with the PKI. So what we are doing to protect our HTTP or HTTPS connectivity and our SSL or our even SSH services.
Exactly, and now is really the time to start looking into this technology and deploying this technology. RPKI is not new. It's been around for several years. The major router vendors, which is Nokia, Cisco, and Juniper, have all supported RPKI for at least 4 to 5 years in their routing implementations. What's happened recently, starting last year, as the internet became more aware and the operators became more aware of this problem and the solution, the ecosystem has really come together. So if you remember the last slide, there's the validation software. Well, a year ago, there was only one validator, and that was the one that was released by the RIPE NCC. Now, today, we have several validation softwares. We have some links on the next slide that we'll show you. And what this has done is it's created an ecosystem where you have a choice of validation software. So you may want to run redundant software. That makes sense. You don't want to put all your eggs in one basket and only rely on one software implementation. So you have a choice in implementations, and you also have a choice in redundancy now. And the other thing that's happened too is that the internet operator community and the RIRs have been very proactive in evangelizing RPKI and really pushing operators to deploy this technology since it's now mature and we have a mature ecosystem and all the tools that we need to support this technology. So just a couple links that we want to leave you with. The most recent case where this has happened last week, where Verizon and an optimization software called Nokia knocked out a large part of the internet. That could have been prevented, again, with proper filtering and with RPKI. And then just some more links about the solution. There's a great RPKI FAQ run and hosted by the NLNet Labs in the Netherlands that has a lot of information. I mean, this is a complex topic. We're just trying to give you an overview in a few minutes, but it has a very detailed explanation of how this software works and all the different pieces. There's The trust anchor at the RIPE validator. This is a web page that lets you type in a particular prefix or an ASN, and it shows you the validation status. And then the last link is also hosted by the RIPE NCC. This has specific router configurations for Nokia, Cisco, and Juniper about how to configure origin validation and how to integrate origin validation into your routing policy. So this is a very useful page if you just need a quick configuration example.
And many thanks for you, Greg, for collecting these links for the guys who is looking these videos. I'll add this slide deck to the web post, so you'll be able just to download this and to go through the links to look for more details, as Greg said. And thank you very much for your time, Greg, today. I think this topic, in the sense that, you know, right now, daily or at least weekly, we could read in the newspapers it was a new cyber attack, or so criminals, governments, whoever else are trying to somehow affect in so being of the other country or other organization, having security infrastructure really is a key to protect yourself, to protect your network, to protect your services from.
Yes. It really is, and I would really urge everyone that's watching this video to take a look at this technology and think about deploying it as soon as you can, because now really is the time. As we mentioned, the router implementations and the ecosystem and the RIR tools are very easy. It literally just takes a couple of clicks on the RIR portal and you've enabled RPKI on your prefixes. It's very simple.
Yes, fully agree with each and every word. So thanks for your time, Greg. Thanks, guys. If you like this video, just share it on the social media, subscribe to the channel, and see you in the next series. Thank you. Take care. Bye-bye.